Okay, the Unit 4 review, it has a lot of different ways that you can solve stuff. So I'm going to be showing you different resources that you can use to solve them, and then you can decide which one is best for you. So Learning Target 1 is about solving systems graphically. So the nice thing about this section is the graphs are already done for you. So when you solve a system graphically, you're just looking for where they cross, and then you write down the ordered pair for those points. So in question 1, looks like it's crossing here and here. So the red line, the pink line are crossing. So the locations, if you go on the x-axis, this is -1, and then this right here is 3. So one of the solutions is at -1, 3. Second solution is going to be at 2, 0. So those are our answers. Question 2, we've got a yellow line and a blue line. They are crossing right here, and they only cross once, so this one only has one solution. So the solution is going to be at 1, 0. When we get to the next page, they don't have the graphs done for us, so we're going to have to graph them ourselves. So I'm going to go ahead and open up Desmos, and I'm going to type in the equations and see where they cross so that I can graph them. So I've got y equals -x. Oh, I got to put parentheses. So negative parentheses x minus 4. Close the parentheses, and I want to square that. And then I'm going to hit +5. So I end up with a graph that has a starting point or a vertex at 4, 5. So I'm going to go ahead and plot that. So 4 to the right, 2, 3, 4, and then 5 up, 1, 2, 3, 4, 5. And then if I look at Desmos, there's a few points on here that I can plot. I can plot the points 3, 4, and 5, 4. So we're just looking for wherever the graph crosses through 4 boxes. It's got to cross right through the corners, so that way we're not dealing with any fractions. The next 2 points look like they're here on the x-axis, and those are decimals, so I'm just going to estimate. So 1.7 and 6.2. I don't usually graph those, but I'm going to go ahead and just do it for this one. So 1.7 and 6.2. Oops, that's not 6. So here's 1, 2, 3, 4, 5, 6. So 6.2 is probably about right there. And if I go up just 1 right here, it looks like 2, 1, and 6, 1. Those are the whole numbers. So 2, 1, and 6, 1. And then we are going to see if there's any other ones. And it looks like way down here, there's one at 1, -4, and another one at 7, -4. So I'm going to try to put as many points as I can. So 1, -4, 2, 3, 4, and then 7, -4, which is right at the edge of this graph. So that's going to be our shape. Then we go to Desmos and we go plot the second one. So the second one is going to be y equals 2x. Oh, I got to delete this. I'm supposed to be on the next line. So y equals 2x minus 6. So my graph on this one, it has a point at the y-axis at 0, -6. And then it looks like it has a rise over run of 2. So it goes up 2 and over 1. So I'm going to go ahead and plot that. So we're starting at -6. 1, 2, 3, 4, 5, 6. And then it goes up 2 over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. And then up 2 over 1. Our goal for doing all of this is to try to see where they cross. This crosses twice, so we have 2 solutions. And you can also tell by Desmos, Desmos will automatically put some points right where the solutions are. So our solutions are at 1, -4, and 5, 4. So 1, -4, and then 5, 4. Those are our 2 answers. This one says the graph and the table form a system. So the circle has already been graphed for us, and now we just have to graph the table. So the first point is at 0, -3, so there's a point here. Then we have 1, -4, 3, -6. Hold on, I missed one. 2, -5. So we're right here. 3, -6. So here's 3, -6, and then 4, -7. And then 5, -8, which looks like it's off the charts, but I'd estimate it's about right here. So this looks like it forms a straight line, and our solution is anywhere where the graph touches the circle. So it looks like it's going to be that point right there. That's 3 to the right and 6 down. So that's our answer. Okay, number 5 and number 6. I'm going to show you one time on a graphing calculator how you can do number 5. I didn't do some of the other ones in the graphing calculator because they didn't say y equals. So actually, let me go back and look at that. Let's make sure. Oh, they all say y equals. So you could have also done these in the graphing calculator. The reason why I like Desmos is because Desmos doesn't require that you solve for y first. You could just type it in however it looks, and then it'll graph it for you. But our graphing calculator, you do have to type it in exactly how it looks, as long as it says y equals. So the first equation, I should probably look at the first equation. The first equation is going to be y equals negative parentheses x, got too many parentheses there, so x minus 3. And I want to square that. And then I'm going to hit minus 2 after. I got a little delay here on my computer, so bear with me. And the second one is going to say x minus 3. I don't want a fraction. X minus 3 quantity squared. And then minus 4. Now, just to save time for this review, you can graph this yourself using Desmos. I just want to show you how to come up with the answers on the graphing calculator in case you choose to use that instead. So let me change my viewing window. Had a weird one going. So there's my answers. The answers are where they cross. So if you notice, the F5 button says G-solve. So we can actually find where they cross by finding the intersection, which is F5 again. So the calculator says that they cross at 2, negative 3. And then if I want to find the second one, I can just use the arrow and toggle to the right. And that's going to be at 4, negative 3. So again, you can graph these yourself. I'm not going to waste time showing you how to graph because we've done that in a previous chapter. The next one, I'll go ahead and just do it on Desmos again. The next one has some square roots in it. So if I go to Desmos, I'm going to type in y equals 2 square root x plus 2. And then I'm going to get out of the square root and hit a minus 3 on the outside. So there's a graph, the first graph, and the second graph is just a line. So 2x, actually I'll put in the y equals. Y equals, it's going to be y equals 2x plus 1, plus 1. So let me get this out of the way so you can see. So Desmos puts dots all over the place. Desmos likes to put dots anywhere it crosses the x and y axis, but be careful because that's not your solution. The solution is where the two graphs cross each other. So the two solutions on this question would be at negative 2, negative 3, and then negative 1, negative 1. Negative 2, negative 3, and then we have another one at negative 1, negative 1. So although Desmos puts these extra dots on the axis, those are not what we care about. We care about where the two graphs actually cross each other, not where it crosses the axis. There will be times where the two graphs cross each other on the axis, but that doesn't happen in this example, so pay attention to that. Okay, so now what we're going to do is take a look at number 7. Number 7 says solve the system of equations algebraically. Now, algebraically says to do it by hand, and to be honest with you, I'm not going to be able to really tell if you're doing them by hand on the test, so you can actually use some of your other resources to do them by hand. This question, though, even though it says that we're in a 2x2 system, this is going to be a 3x3 because it's got 3 letters in it, but it doesn't matter. We could still do this by hand. And I actually like this one because as the problems get shorter as you go down, that means that it's actually set up for a process that's called back substitution. So what we do is we start at the very, very bottom, and that's already done because it says z equals 5. If that wasn't done, I would just solve it, and now I can work backwards and plug it into the previous problem. So I'm going to have y equals 2, and then the z has an answer. Oh, not y equals, just kidding. Let me go back and start over. So this guy right here is going inside here. So this is going to say y plus 2, and then parentheses equals 13. Since z equals 5, I took out the z, and I'm going to stick the 5 in there. So that makes this problem y plus 10 equals 13, and then I'm going to subtract 10 from both sides. So we have y equals 3. So now that we have the answer for z and the answer for y, now we can go back and plug in the answer for y and the answer for z into the top problem. So my top problem is 2x minus 3 parentheses plus the z turns into a parentheses and then equals 10. So I'm going to go ahead and go do my back substitution by taking the two answers that I have and plug them back into the original problem on top. So I put in a 3 here, and I'm going to put in my 5 here because this was the x, or this was the y and this was the z. So I have 2x minus 9 plus 5 equals 10. Negative 9 plus 5 combines to negative 4. And then we have to add 4 to both sides. And we get 2x equals 14. So then we just divide by 2. And then we have x equals 7. Now, since this one has 3 answers, we have to make sure that we write it sort of like an ordered pair, but this time it's going to be an ordered triple. And when it says, when I say ordered triple, it's because it's going to be in alphabetical order. So the x has to go first. So 7, comma, y is next. So 3 is next. And then finally the z, which is 5. So that's my answer. Now the second equation, this one has an exponent in it. I will show you how to do it by hand, but I mean, technically you could do this one on Desmos too. So I'm going to go ahead and do this by hand first. I want to stay away from the y squared for right now, and I want to work with the bottom equation, and the bottom equation has this 1 on it. So that's going to be the one that I'm going to solve for. Anytime you have these exponents, you probably want to do this by the substitution method, which if you were in my class, I told you numerous times I hate, but that's probably going to be the easiest way to do this if you're not graphing. So if I was going to solve this, I could move the y over to the other side and then the 2 back over. So if I add the 1y over, I'll end up with a y on this side. And then if I subtract the 2 over, it'll say 2x minus 2. Now this guy right here needs to be plugged into the first problem. Since it says y equals, I'm going to stick it in this part right here. So I'll end up with parentheses squared equals 8 parentheses x minus 1. Now, the reason why we draw this circle right here is because we are going to start by plugging in that circle somewhere, and then we're going to end by plugging in the answer that we get into that circle. So the stuff from that circle has to go inside these parentheses because we know the value of y is 2x minus 2. And anytime you have a squared, you're going to have to write it twice. So this is 2x minus 2 multiplied by 2x minus 2. So you're going to have to multiply this out, which is basically like foiling. So this is 4x squared. Then you have minus 4x. You have another minus 4x. And then negative 2 times negative 2 is positive 4. So on the left side, we simplify this, and these two become negative 8x. And then we have a plus 4. And now we can start worrying about the right side. The right side has a parentheses, which I need to get rid of. So I'm going to distribute the 8. So this will give me 8x minus 8. And then I need to move everything over to one side. So if I subtract 8x over, I'll end up with a negative 16x in this spot. And I'm going to go ahead and add the 8 over, because the only way you can solve these is if it equals 0. So now this should equal 0. And then I have a plus 12 right here. And then we have the 4x squared out in front. Now, I'm going to try to factor this. Not everything factors, but I am going to try to factor this. So I'm going to go into my calculator. This looks like it's a complex ABC at first glance, but maybe not. So what I want to do is I want to check to see if there's a GCF I can pull out, because anytime you have a GCF, the number shrinks. So that's a good thing. So you're going to hit options, F6, F4, F6, and then F2. We want to find if there's a GCF between 4, comma, 16, comma, and then 12. So if I close this, this guy right here tells me that the GCF is 4. So I should be able to divide everything by 4, which should shrink the problem and make it a lot easier. So this is going to be x squared minus 4x plus 3. Now, the cool thing about the calculator is if you are in my class, I showed you guys how to sort of work backwards by using the solver in the calculator. So that's what I'm going to do next. So in the calculator, we have this solver that works on all polynomials. Polynomials are pretty much anything that have an exponent in them. So F2 is our polynomial solver. And the only things I'm going to worry about are the numbers inside the parentheses. So on the actual polynomial, we have a 1, a -4, and a +3. So that's all I have to enter into the calculator. Now, when it says, what is the degree is the highest exponent of the problem. So the degree is going to be a 2. So I'm going to stick in a 1. Then I'm going to stick in a -4. So -4. And then I'm going to stick in a +3. And once I hit execute, it's going to give me my 2 answers. But here's where you need to be careful. Your factors will be the opposite signs of your answers. So my factors to these problems are going to say x -3, x -3, and x -1, since the calculator told me that they were both positive. And then I am solving this, so I mean the calculator gave me the answers. The answers are x = 3 and x = 1. Now, since I have 2 answers here, let me circle that just a little better because I don't want you to not see the 3. Since I have these 2 answers, I'm going to have to go back to the circle and go plug it in. And I'm going to have to do it 2 separate times. So for x = 3, we would end up with y = 2 parentheses -2. We plug in the 3. And so this guy right here is going to say 6 - 2, which is 4. So when x is 3, y is 4. The second one that I'm going to try to plug in is x = 1. So y = 2 parentheses -2. And then I stick in the 1. So 2 times 1 is 2. And then I have to subtract 2 from that. So I end up with 0. So when x is 1, y is 0. And again, there's more than one way to do these problems. This was how you do it by hand. If I really wanted to, I could avoid all of that and just go into Desmos and type it in. So I'm going to show you real quick how to type this in. This is problem 8. So we're going to stick in y squared. So y squared equals, I forgot what the problem was. I think it was 8 parentheses x -1, x -1. So we get this parabola that's pointing to the right for the first equation. And then the second one, what was the second one? The second one was y equals, let me go check, I forgot. Oh, 2x minus y equals 2. So 2x minus y equals 2. And again, if you notice the answers, these are the same exact answers that we got by solving it by hand. The graph said it was at 3, 4. So here's 3, 4 right here, and 1, 0. So will I be able to tell how you're doing it on the test? Not really. But you should know how to do these things by hand in case they give you one of those questions where they say, someone did the problem wrong, go find the mistake. Okay. Okay, so for the next one, on number 9, I want to do this by hand also. You guys heard me say earlier that I hate the substitution method, but this one is actually set up for the substitution method because it already says x equals. So the substitution method is where you circle the answer and then you go plug it into the other problem. So we're going to put that, since this says x equals, we're going to put it in right here. So I'm going to stick in parentheses here, plus 3y = 3. And then I'm going to stick in the stuff from the circle in here, so -3 minus 3y. And then if I solve this question, there's a 1 out in front, so this is -3 minus 3y equals, oh, actually I forgot the 3y. So -3 minus 3y, and then I want to bring down the plus 3y equals 3. And then I want to combine like terms. When I combine these like terms, they basically cancel, so I'm left with -3 = 3, which isn't even true. That's false. So what the heck is happening here? Here's what's happening. Let's go into Desmos so we can investigate this a little bit further. if I look at the graphs, my goal is to find where they cross. So one of the equations was x plus 3, y equals 3. So it's just a plain, simple line. And the second one says x equals negative 3y. So negative 3y minus 3. So if I get this stuff out of your way so you can see, even if I zoom out, you're going to see that these lines, they run right beside each other forever. So in other words, they're parallel. Well, that's an issue because anytime we're trying to find where they cross, if they're parallel, they're never going to cross. So that's what happens when you try to do your substitution. If you lose all of your letters because they crossed out like these two did, if the remaining answers are not equal to each other, then there is no solution. The only other thing that could have happened is these last two numbers were the same. If those two numbers were exactly the same, then that means that the two lines are on top of each other, which means that they're always crossing. And in that situation, we would say infinite solutions. Okay, for the last one, actually for the rest of them in this section, I'm just going to type them into Desmos real quick so that way I can get to some of the other stuff that's on this test. So let me go ahead and let's do, what are we doing? Number 10. So number 10, if I just type it into Desmos real quick, it's going to say x squared plus x. Oops, I don't know why that put in a subscript. So I want x squared plus x minus y equals 12. And then the last one is negative 3x plus y equals negative 4. Negative 4. So our goal is to try to find where they cross. So one of the points is at negative 210, and the other point is at 4, 8. So those are our solutions. Negative 2, negative 10, and again, we're going to have a solution at 4, 8. Hey guys, I'm going to be honest with you, even though this says to do it by hand, I really don't care how you do it. If you have the resources, if you have the technology, I always say use it. In real life, when we solve real life problems, we don't really sit down and, you know, solve equations by hand. If we have knowledge about solvers and stuff like that, we plug them into the solver and then we try to make sense of them in the real world. Let's see what else we have. Let's go back to the review, not that one. Number 11 and 12, I'll just go ahead and do them in the Desmos real quick again, just so I can hurry up, because I don't want this video to be too long. So this one right here is going to say 3x squared plus 4x and minus y equals 7. Now, if I was going to do this in the graphing calculator, I actually would use Desmos instead of the graphing calculator because Desmos lets you type it in no matter what. Like, you don't have to do any math whatsoever. You can just type it in exactly how it looks. But on the graphing calculator, it only works if it says y equals. So in these two equations, we would have to solve for y first in both of them. And that kind of scares me a little bit because if you mess something up while you're solving for y, it's going to throw your whole answer off. So this one right here is very similar to the last one we just did. This one right here is, what is this? Negative 2, negative 3. And then this guy right here, it's a decimal. If we have answers, like let's say it's multiple choice, if we have answers that don't have decimals, you can just convert your decimals or your fractions into decimals from the choices. So like, for example, let's say one of the answers was 4 over 3. You can just do 4 divided by 3. See, and it gives you 1.33. So you can figure it out that way. So let's see what we got here. We're going to have negative 2, negative 3 for one of the solutions, and then we have the 1.33333 forever, and then the other one was 3.66667, whatever. So I'm going to round it. So those are our two answers. And then the last one, I'm going to go ahead and just type it into Desmos so I can hurry up with this video. So we're going to have, let's see what we had. I forgot. Y equals negative x plus 15. So y equals Yeah, negative x. So negative x plus 15. And then the next one was parentheses x minus 5. So y equals parentheses x minus 5 quantity squared. And then what was it? Plus 4. So we're trying to find where they cross. It looks like they cross twice again. So one of them is at 7, 8, and the other one is at 2, 13. 7, 8, and we got 2, 13. Okay, so now what we're going to do is we're going to get into our systems that have 3 letters in them. I'm going to show you how to do one by hand, and it's not very fun. It's actually a lot of work because our goal is to make it so it has less letters. So looking at these 3 problems, the first thing I notice is that this one only has 2 letters. So what I'm going to do is I'm going to use the other 2. So I'll use row 1 and row 2. I'll use those 2 problems, and I'm going to make the z's disappear. In order to make the z's disappear, this z needs to have a 2 in front. More importantly, it needs to have a negative 2 in front. So since these are both positives, I'm going to have to multiply this one by a negative in order to get them to cancel. So I'm going to have to multiply it by a negative 2. So when I do that problem and distribute it all across the entire problem, I'll have negative 2x minus 2y minus 2z equals 4. Minus 4, sorry. The second one, I'm not going to touch it because I'm going to have negative x plus 3y plus 2z equals 8. And see, the whole thing on this question is we want the z's to cancel because this problem over here doesn't have any z's in it. Now, if we had a problem that also had the z, we would have to do this 2 different times and pick a letter to cancel. I'm trying to do it the shortest, fastest, easiest way that I know. We use black instead. So I'm going to end up with negative 3x plus y equals 4. So now what I have are 2 problems that only have x's and y's. So I'm going to create a system with those 2. So I'm going to put these together. 4x plus y equals 4. And then I'm going to have negative 3x plus y equals 4. Now I want to get letters to cancel again. And to me, it looks like the easiest one to get to cancel is going to be the y's. If these y's were just opposite signs, they would cancel right away. So I'm going to take the top one, or you can do whichever one, it doesn't really matter. I'm going to distribute a negative 1 throughout that question. So I'm going to have negative 4x minus y equals minus 4. And then the second one, I'm going to just leave it alone. So this is 3x plus y equals 4. So I'm going to combine these 2 equations together. So I'm going to be left with negative x. These cancel, and that happened on purpose because that's the whole reason why we did the multiplying, equals 0. So I just divide by negative 1, and I end up with x equals 0. So now we just use back substitution. We go back into one of the problems that only has an x and another letter. There's 2 of them, so we could either plug it in here or here, and you guys know how I roll. I try to stay away from negatives whenever possible, so I am definitely going to try to use this one instead. So I'm going to go back and plug this into 4x plus y equals 4. And I love plugging in 0 because 0 just makes this cancel. So that means that my second answer is y equals 4. Now I do back substitution and I go back into one of the original problems that has 3 letters in it. I'll probably use the first one, the one at the top, because it's full of positives and it has a lot of 1s in it, so I love that. So I don't know the answer to z yet. I know the answer to x and I know the answer to y. The answer for x was 0. The answer for y was 4, and I don't know the z yet. And that's going to equal 2. And that's because, I know this is getting messy. That's because I am using, let me use this purple, I'm using this equation here. That's the same as this guy. I just plugged in all of the answers that I already found. So this guy right here, this gives me 4 plus z equals 2. And then I just subtract 4 from both sides, and I get z equals negative 2. So my final answer should be written as an ordered triple. So x goes first, and then y, and then z. So that right there is my final answer. Now that was very long-winded and a lot of work. So I want to show you another way you could do this. You could also use your graphing calculator. Your graphing calculator has a solver in it. If you go back to the menu to your equation solver and get to where you select the type of equation you want to solve. Now I'm going to go ahead and grab my eraser because I can't see the questions anymore. So I want to be able to see that so I can figure out what I'm going to type in. So since we're working with multiple problems, we're going to use the simultaneous solver, so F1. It's going to ask you how many letters are in the question. So we have an X, a Y, and a Z, so it's 3 letters. So I hit F3. Now someone already used this problem solver thing, so I'm going to clear it with the F3, so it gives me all zeros. And the cool thing about this is you don't have to put any numbers in. You just type in the numbers from the front. So I'm going to stick in 3 1s and a 2. So I'm going to hit 1, 1, 1, 2. And the next thing I'm going to stick in is you got to be careful with the signs. This is a -1, a 3, a 2, and an 8. So I'm going to stick in a -1, a 3, +2, and a +8. Now here's the part where you need to be careful. If you guys notice the problem, these problems are in order. Let me erase all this again. These are set up in order, so the first row is the first column is all of the x's, the second one is all of the y's, the third one should be all of the z's, and then the last one should be all of the numbers. You're going to notice the third one doesn't have a z though, so that means that the z is a 0z. So when we type this in, we're going to stick in a 4, a 1, oops, and you want to be extra careful because one mistake, one mistype, and the whole thing is messed up. 0 for the z, and then 4 right there. And you can see we get 0, 4, -2, which is exactly what we got when we did it by hand. To save time again, I'm going to go ahead and just do these in the calculator. So let me exit out of this so I can clear it. So this is going to be 2, 2. Oh, no, that's not a 2, that's a 3. So 3. Delete this. So 2, 3, -2. That's one thing that I need to talk about. Let me go back real quick. When you stick in these numbers, the signs right before them go along with them. So I have, for that z value, I have to stick in a -2. So -2, then 4. The next one is going to be -2, -1, -1 again, and then -14. And then we have 3, -1, 2, oops, 2, and then 14. I like to do a quick check just to make sure I typed everything in right, because like I said before, if you don't type something in right, let's say you mess up a sign, you get an error. And an error usually means that the 3 things are not crossing anywhere. But if you typed it wrong, well, that's the reason why they're not crossing anywhere. So my answer for this one is 2, 4, 6. And then the next one, let's see, let's go exit so I can clear this out again. Oops, this has 3 unknowns. So we're going to clear this out. Now you have to slow down because notice in this first one on number 15, the y is missing. So for the y, we're going to stick in a 0. So this is going to be -2, 0, -2 for the z, 4, -1, 1, -3, -6, and we have a 3, another 3, 1, and then -14. So I'm going to just double check again. So -2, 0, -2, 4, -1, 1, -3, -6, 3, 3, 1, -14. So my answer is -6, 0, 4. Pretty easy stuff when you've got a calculator. Okay, final couple of questions. This one doesn't ask you to solve anything. It just asks you what row operations you would have to use to create an equation that eliminates the y's. Now, the way I showed this in my class is this is row 1, this is row 2, and this is row 3. This question is only asking us about row 1 and row 2. So we could care less about row 3. So I'm just going to get rid of row 3 right away. The question is also just asking us about eliminating the y. So if I only care about y, I don't really care about any of the other letters. So I'm going to get rid of this because it's just a distraction. And I'm going to get rid of all of this because that's a distraction. So I have a positive y. Let me get the eraser because I used the thing a little too thick here. I have a positive y. So you can see it maybe. Can you see it? I shouldn't have used such a thick marker. I'll just go like this. I have a positive y and a positive 3y. So they're asking me, what do I have to multiply in order to get those guys to cancel? Well, if I need these things to cancel, they have to have the same number but opposite signs. So that means that for row 1, I would have to multiply it by 3. Now, if I just multiply by a regular 3, they're not going to cancel because it's going to be a 3y and a 3y. That would make 6y. So I would actually have to make that a -3y. And then I would have to add that to row 2. And I don't have to do anything to row 2. I mean, you could say multiply by 1, but multiply by 1 doesn't do anything. So that's a shorthand way that you can say it. Or you can just write it out, multiply. And this is how I think it's going to be on the test. Multiply row 1 by 3. And then actually, we don't have to multiply anything to row 2. So this is what we would have to multiply. I'll show you that one more time. So it says row 1 and row 3. So this is row 1, row 2, row 3. And since it doesn't say anything about row 2, I'm just going to get rid of it so it's not a distraction. And then it also says eliminate the z. So if I want to eliminate the z, I don't really care about what it's equal to. And I also don't care about the x. And I don't care about the y either. So since we're trying to eliminate the z, I need to figure out what to multiply. The signs, if you notice the signs, they're already opposite. So when I do my multiplying, I don't have to use any negatives. The only thing row 3 needs is a 2. So I'm going to go ahead and multiply row 3. I want to multiply that by 2. And then I want to add that to row 1. And there's different ways you can write this. You can write row 1 added to 2 times row 3. These are exactly the same thing, so it doesn't really matter how you write it. You want to say something like using words, what would you do? You would say multiply row 3 by 2. So there's 3 different ways you could write the answer, and they all mean the same exact thing. So you would just have to make sure that you combine your answer here to row 1, and then they would cancel together. Now the last section, I'm not going to go over these because these are review. So these are the topics. It says find the inverse from an equation. Don't forget, when you find the inverse, you just switch the x and the y. Switch x and y, and then you just solve for y. If you need examples, you can go into Canvas and look at some of the slides in Unit 0, Lesson 5. Composition of functions. These are the types of questions where you would do something like this. F of g of 2. You can find that in Unit 0, Lesson 2. Factor a sum of cubes. So that's where you need to take a problem that looks something like this, and you need to write it so it's all completely factored. These are those SOAP questions that we talked about. That's in Unit 2, Lesson 4. And then the last thing you have to do is find the domain from an equation. And then we talked about this in a few different chapters, so I'm not really going to list where to find that. Remember that when we talk about a domain, it's always going to be all real numbers. All real numbers means negative infinity to infinity. Unless, and that's a big one, unless you see a fraction with x on the bottom. If you have a fraction with x on the bottom, so x, something like this, I don't even care what's on top, but if you have an x at the bottom, you have to set that equal to 0 and solve. This is going to be your bad number. So if I was going to write a domain for something that has an X on the bottom, I would find the bad number and then write it twice. That's how you skip over a bad number. So the domain right here means all numbers except 0. And if you had a radical with an X, that's just a little different. You would take that and set it greater than or equal to 0. And so on this question, you're going to find your answer, and it's going to go forever. And we include that number. So that's it for Unit 4. Hopefully you guys find this useful, and hopefully with all of the calculator and Desmo stuff that I showed you, we can rock this next test.